We're interrupting our scheduled program to bring you details of a big quake in Christchurch. Buildings already damaged in the September quake have been damaged again, and others have collapsed.
Christchurch was devastated by powerful earthquakes. But today, it stands as a symbol of resilience and smart rebuilding. Most major earthquakes strike along the Pacific Ring of Fire, affecting countries like Chile, Japan, and New Zealand. On the 22nd of February 2011, a 6.3 magnitude earthquake hit directly beneath Christchurch. As a shallow earthquake, it was particularly deadly and destructive. 185 lives were lost, and 80% of the city centre was severely damaged. The earthquake's shallow focal depth, combined with soft soils conditions and the vulnerability of outdated concrete structures, led to widespread collapse and ground failure. Before 2011, Christchurch relied on reinforced concrete and unreinforced masonry, vulnerable in strong earthquakes. After the earthquake, engineers increasingly turned to steel for its flexibility, strength, and capacity to be repaired efficiently after seismic events. Supported by clear, code-compliant guidance and best practice information, this approach helped streamline design decisions and contributed to the Christchurch rebuild. Today, a broad range of steel-based seismic systems is used worldwide to enhance building resilience. For example, buckling-restrained braces, or BRBs, allow a confined steel core to flex in both directions without significant buckling, keeping buildings stable with minimal sway. Eccentrically braced frames, or EBFs, focus movement into a replaceable steel link. After an earthquake, just unbolt and replace the dissipative links designed for disassembly. Slide-in hinge joints use controlled friction to dissipate earthquake energy, reducing damage by allowing movement at key connection points. Dissipative rocking frames lift during shaking, then settle back gently, protecting the structure and keeping it upright. Base isolators separate the building from the ground, reducing quake forces by up to 70%. A clear example of these solutions in practice is Tipuni Village in Wellington. Rocking frames and sliding joints keep the structure centered and quick to repair. After the Christchurch earthquake, the HSBC Tower on the banks of the Avon River in Christchurch suffered minimal structural damage. Research showed that none of the yielded active links required replacement. Steel components are prefabricated, quick to install, and recyclable. They lower emissions, save energy, and reduce construction time. From high-performance braces to replaceable links, steel helps structures to dissipate seismic energy, recover quickly, and build safer, more resilient cities.